So here's the deal. We're going to be using logs for the next genuinely 3 weeks, and you have to be able to, you ready? You have to be able to work with them. So like exponential properties, when we have this property, x to the third times x to the 7, we know that's not x to the 21. When we multiply, we add the exponents. So logs work kind of the same way. They got some weird things that you got to do, and that's what we're talking about today. So there are 3 properties that you need to know, and we're going to talk about how to write logs out the long way. That's called expanding them, and how to squish them. So the first property that we are going to talk about is called let me make sure I'm actually saying this correctly. Yep, I did it right. So the first one is called the product property. Right? And you've seen this last year, but this is going to make it super nice for you, super easy. So here's what the product property looks like this. If we have log base, let's see, where they use it. Oh, they use a log base b x times 1. Okay, so that's what they give us, right? So if I have 2 numbers that are multiplied together or anything multiplied together, when I have logs, I can stretch them out using, and here's what's crazy, addition. So it equals log base x plus log base b of y. So when they're squished together, you multiply them. When you stretch them out, you add them, right? So that is our first one. So we're going to try some random ones. You want to do it on your whiteboard desk, you can. You want to put them on your paper underneath here. I'm going to give you a bunch of examples using this property. So here comes our first one. So on these ones, I would like you to do me a favor and to stretch these out. So I'm going to start with this. Log base 3 of 5x. I would like you to please stretch that out or expand it, right? So that's what we're doing first. We are expanding it. So if you said, hey, Miss T, that's log base 3 of 5 plus log base 3 of x, you are on fire, right? Nice and easy, nothing really tricky there, right? What sometimes is more interesting is going the other way, because expanding it, pretty easy to do, swishing it, a little more tricky. And the next ones we're going to do is called, we're going to do a thing called condensing. Oh. When we condense, we take something that's got the word, yeah, because I need your water. We want you to take the word log that's written a bunch of times and write it just one time. So we want to squish it down. So it would look like this. Log base 3 of 7 plus log base 3 of 5. And I don't want it written with that much stuff. I want to squish it all down. And so what first thing is, they got to have the same base. They don't have the same base, we can't do it. So we're going to rewrite it using the word log just one time. We squish it together, and 5 times 7 is going to be 35. We add when we expand them, when we squish back together and multiply. Yes? Are we okay on that? So I'm going to wait a second, and I'm going to give you a couple to try. Okay, here's a few for you to try. Here comes the first one for you to try.
What if you like almost out with it? Hey, Mom.
So this is why we like condensing. That's can we squish that all down so it's a nice, easy problem to do when we are ready to start solving these. And we can. We're going to go ahead and write the word log base 3 just one time, right? So we've got log base 3. And then we remember when it's stretched out, it's plus, but when we go backwards, we multiply everything together. So if you did that and you got 56x, you are fired. Yeah. You okay? No one's good? Let's try one that's a little bit trickier. You guys can do this one. How about this? How about
it was log base 3 56x.
How about this one? You know, I spent so much time building my lesson for the other two classes, and it just was crap. And now I'm so happy. I swear to God, you guys get such better grades.
Okay.
Is that why we get better grades?
I swear to God, I'm such a better teacher.
Are you sure we're just not the smarter class?
No, I'm really better. By the time I get to third.
So we're not the smarter.
Well, you might be, but also, are you ready? Did you come up with this? Did you say log base 2 of 20x to the third? If you did, you're fired. Let's do one last one, and this is why the lesson on the other class went so badly. This was problem number 2 for them, and that was bad. So here's what I am going to ask you guys to go a little further on this problem than you think you need to. I'm going to give you a little hint on this problem. This problem, at the very end, is going to be just a number, a very small number. Now I'm going to walk you through why it's going to happen. This only is going to happen sometimes, and it will only happen if there are no letters, no variables. But in this case, we're going to start, because this is pre-calculus, watching for ones that we can go an extra step on. We're going to talk about what that extra step is real quick. So here we go. Most of you were like, Miss T, I don't know why you're being so weird about this. We got log base 10 of 4 times 25, which is 100. Yay, why is that hard? Because when we have all numbers, we need to do one last thing, and we need to ask ourselves, can I turn 10 into 100 using an exponent? In other words, why does that happen? Here we go. We're actually solving this guy. Does it happen all the time? No. If this had been 103, could I turn 10 into 103? No, I couldn't. But I can turn it into 100. What exponent turns 10 into 100? 2 does. So the actual answer to this whole crazy thing, here's what's crazy. It's just 2. It's just 2. Do we do these on your homework a lot? No. Tomorrow we'll practice some of these, but I just want to throw it out for tonight.
So if it was log base 5, 25, the answer would also be 2.
Yes. And if it was log base 3 to the 27, yes. That's pretty good.
Maybe she doesn't hate you.
You want to actually say something even cooler?
I don't know.
So watch this.
Yeah.
It's weird.
I thought. Did not get over.
Squish it together, right? Great. Now watch this. I could do that way. I could have also done this. 3 to the what gives me 3? 3 to the what gives me 9? 2.
I like that.
Yeah. So So that's why they work, right? Because it turns out what we're doing is we're adding the exponents. And that's why this property works. Because it's like, why do we add here? Because each of these really stands for an exponent. And we add the exponent. I like that. Nice. How about what happens if we're dividing numbers? Here comes our next property. It is the old division property. I got 3 problems. The next one. This one's easy too. So just like, because again, logs are actually exponents, and when we are having exponents somewhere on the top and somewhere on the bottom, we subtract. That's good on this? No?
It's actually way down.
So Lee, you might want to write this down or just at least watch. So this is going to look like this. Log base b of x, but anything on the bottom is now subtracted. Log base b of y, right? So that's really all the difference between multiply and divide, is that if it's on the top, you're going to be adding that stuff. And if it's on the bottom, you're going to be subtracting. So let's take a look at some properties to expand, and we'll look at some to contract. So here comes the first one, to expand. So it would look like this. Oops, that's not right. We're going to write this out. Log base 3 of 2/7. I want you to expand that. So here's what I'm going to do. I'm going to say, oh, I've got really 2 little things happening there. Log base 3 of 2 minus log base 3 of 7. Now, often I'm going to make sure, does 2 turn into 3? No. It's some weird decimal. Does 3 turn into 7? No. So I'm going to stop there, but that's how that
Wait,
works.
so we should turn them into the real numbers like the example we did with the.
You could, and then you just subtract them. So that same problem we did, you could do 27 over 3, and it would turn out to be 2 again, because it's going to be 3 minus 1. Nice. Okay, so let's try something like this. Let's say, what if I want to squish this guy together? Log base 3 of 5x. Oh no, let's make this interesting. 25 x squared. Sorry. So, Justin, we're going to go ahead and we're going to put our computer away, please. Thank you. And then do this problem. Now close it, like, just close your computer. Oh my gosh. Like I not on tape. I haven't just had teenagers as children.
I hope that everybody who's listening to it closes it.
That's right. Everyone, close your computer. Stop doing that. Let me see. 25x squared over 5x. Now you could leave that, but you can clean it up and say, look how nice this problem turns into 5x. Awesome. Awesome.
I know it's a stop.
Yep. We got one last property to do, and then we're going to try some where we put them all together, and you'll actually not hate those. The last property is my favorite, and it's the most important, and it is called the power property.
I have a C because you won't put my economics USA in.
So here's the key. This is kind of the key to the whole thing. When I say to you in the next few weeks, take the log of both sides, the reason that it's going to work is because finally we're going to have a way to take things out of the attic. And when we have an exponent in our problem, what we're allowed to do with the product property of the power property is take him, and if you remember this from last year, we take him and we drop him down in the front, right? And that's what's really nice. It gives you y to the log b of x. We take any powers. We don't want to have our logs to have extra powers. So we drop them down into the front. And it's really nice and easy. So we'll do a few examples and then we'll try a few where we put it all together. And then I'm going to shut up. And then you guys are going to work on yourself. All right, well, I just want to try.
I like this.
Okay. So try this one. Let's expand this guy. Nice and easy. We're going to start with a nice, easy one. Let's start with this. X to the 5th, right? Let's start nice and easy.
Yes.
And then we're going to do a cool one that you guys are going to like. It is nice and easy, nothing crazy there. All you know is anytime, Justin, you see, really because I yelled at Justin. Anytime you see an exponent in your log problem, you're just going to drop it down to the front. So 5 log 3x. Okay, let's get a little crazier on this one. How about this? Now, remember yesterday, if you remember yesterday, I told you that if you take the log of itself, it cancels. Here's why. Watch what's going to happen on this problem. Let's expand it. Let's drop this 7 into the front. So we get 7 log base 3 of 3. And what turns 3 into 3? 1 does. So look what happens. That's why, remember when I said I will explain it more, why they kind of cancel each other out? They don't truly cancel each other out. That just becomes 1, and when we dropped it to the front, the 7 is all that's left. That's why these properties work. That's why they work. Let's do one last one where we're going to go. No, let's not. Let's put them all together. We got this. Yes, you'll like this. Oh, God.
Yes.
Okay, here we go. These are my favorites. I would like you. Do I want to start with expanding? Let's expand.
Those cheese he's getting. Smoothies. All those seeds in there.
I got a little hairball there.
He loves that for us. Awesome video.
We are writing it out. We're stretching it out. We're going to use the word log. Let's count how many times we're going to use it. We're going to use it 1, 2, 3 times. So I'm going to walk you through how I do it, and then you might decide that you do it in a slightly different order.
Okay, when you separate it, you're gonna get log base 2x plus, then would it be 3 log base 3y?
2 log base. You knew that. Yes.
Swear to God.
Yes. So I'm gonna do it exactly like Jordan walked me through. So here's what she said. She said log base 3 of x. That guy's good. And then I'm gonna go plus. Now watch what I'm doing. I'm leaving a little space because I often will take care of that exponent at the end. So check out what I'm going to do. I'm not done yet. I don't want exponents in my problem. So don't forget this. Well, I wonder if he'll do it. This would be so cool if he'll do it. Oh, no, that would have been cool. So this little dude walks down here, and there he is. So that is this guy expanded. Nice and easy, nice and pretty. How about one with a little divide in it? Let's do one with a little divide in it. We are expanding it as well. Love it. Look at them. They're so easy.
Yeah.
Justin, I'm done, Justin. Jackson, are you done with this one? Anyone else with you? Okay, you weren't, but okay.
Me when I'm alive. Me when I'm alive.
Here's what I got. So some of you are going to do it in 2 steps, but some of you are going to realize, hey, each time I've got an exponent, I'm going to put it in the front. So some of you are going to get pretty fast. Plus 3 log 3y minus, careful on that guy, 5 log 3z. Nice. I like this stuff. I do like this stuff.
So yesterday's amount of lies. Just not sad.
You wouldn't stay on a mountain of lies.
Now it's condensed.
Just see with your full green page full of 150 problems.
Okay, how about this one? I like this one too.
Golly.
But actually, it's just a 2 and a 1. So you're solid.
It's a 1/2, right?
Yeah.
Yeah. Hey, guess what? I don't want a root in there. Make it into an exponent, right? We know what the roots are as exponents. It's just 1/2. So slam a 1/2 up there. You can do it in 2 steps if you like. But for me, anytime I see that square root, I'm just telling myself, wait a second, you're just 1/2. You're trying to trick me.
This is just yesterday's stuff.
Now, I want to be honest, I have 2 different forms of software that I'm using. So some software will write the answers like this, and I like it like this. This works for me. That totally works for me. But sometimes my software will do this instead. Do you see what it did there? It just took that 1/2 and put it on the denominator. Is it like, it's the same. It's the same answer. But I'm not going to lie. Because that 1/2 looks like a 1/2 to me, that makes me happy, personally. But it's both are right. So I don't want you to get to an answer and feel like, I got it wrong. It's a 3 under the bottom. It's like, yeah, it's just 1/3. That's just what they did there. And then I'm going to minus 4 log y. I forgot the 2 because I get bored of writing these. I think I got one last one to do, and then we are quit. How about, can we try going the other direction? I think we can. Oh, I love this one. I love this one. Last one. Last one. Last one, best one. Here we go.
I know.
Done.
No, that's it.
Yes, yes, there you go. Oh, I have one of these. Good stuff. You have a 28 in your answer somewhere, that would be awesome.
Wait, it's 7 times 4. Yeah, but where did you go before the log?
So here's what I'm going to get. I'm going to write log once. Here's what I got. So it's going to be 4 times y times 49 to the 1/2, right? 49 to the 1/2, that's square root. And hey, I actually know the square root of 49. It is 7. And you could write it like this. That's not wrong. It's not pretty, but it's not wrong. But if you wrote it like this, 28y, that is even prettier. I will say I've got one other thing to say, and you don't have to write this down. You can just watch this. Different teachers are going to teach things slightly differently. So watch this problem right here. You're going to have log base 3. You don't have to do this. X squared, y to the 3rd to the 5th. Now, I have some teachers that will say put the 5 out front and use parentheses. I'm gonna be really honest. You guys suck with parentheses. You just really are bad with where to put parentheses. So we're not gonna do that. If your teacher last year said, oh, if it's got an exponent and more exponents, use a parenthesis. Here's what works better for me. Just go ahead and distribute this, dude, right? So just go like this. So it's going to be x to the 10, y to the 15, and then it's really easy, right? Then it's a really easy problem. But could you do it by putting a big parenthesis on the outside and having that 5 and then having everything else? Yes. So sometimes your answer might not match the answer key because sometimes my software does that. I think it sucks. I don't like doing it. I am done. We are done. You're going to finish your homework in class because it's that quick. And I'm going to stop taping. And the answer